So before we start, a little bit about me, for those who don't know me yet. I'm Dirk Mollema. I live here in the Netherlands, so it's well, close to home for me. I work at Outsider Security, which is my own company that I started last year. I do a bit of a mix of hacking, research, writing blogs, giving trainings, doing consultancy, so a bit of everything. I really like to give talks, so to share my knowledge with other people. So I've given talks at several conferences in the past, and very happy to be here at XeveCon for the first time, not the last time, I hope. As part of my research, I usually write my own tooling, and I publish that tooling as open source, so you can find several of those on my GitHub. I also have a blog at dirkm.io, and if you want, you can follow me on Twitter to keep up to date with all the stuff that I do. So today we're going to be talking about Windows Hello for Business, from here on shortened to WHFB, because I don't want to type out the whole thing all the time. I'm going to look at what exactly it is, which flavors of Windows Hello for Business you have, so in which ways you can deploy it. And then have a little bit look at the internal things, so that the key enrollment process, how the keys are used in the various stages. And then on to the fun parts, or at least for the red teamers among us, bypassing MFA with Windows Hello for Business, some lateral movement, and also looking at how Windows Hello for Business works in hybrid setups. So first of all, Windows Hello for Business, or the normal Windows Hello, basically is one of Microsoft's passwordless authentication offerings. So we all know that passwords, well, we're all bad at picking passwords, especially if one thinks that a normal human being can have unique passwords for every website that he has an account at, which is never going to happen. So people pick simple passwords, people reuse passwords. And as part of that, Microsoft has been working on new ways to authenticate, which is one of their passwordless authentication solutions, and Windows Hello for Business is one of these offerings. And basically the idea about Windows Hello for Business is that it uses cryptographic keys that are stored in your device, and you unlock these with a PIN or with a face recognition or with a fingerprint, or basically you have a key that's stored on a device, and you unlock that key on your trusted device, and that you use to authenticate. So you basically replace the passwords with a key that's stored on a trusted device somewhere. And you can have Windows Hello for Business in several flavors. You can have it only in your on-prem Active Directory, you can have it only in your Azure Active Directory, or you can have a mix of both, so you have a hybrid setup. Basically, the idea is that you have that key on the device, and you use that to authenticate to, in this case, Azure AD, since we'll be focusing on Azure AD in this talk. I just wanted to highlight some prior work. So there have been some people that looked at Windows Hello for Business before. One of the most interesting ones, I think, is the talk Exploiting Windows Hello for Business by Michael Grafnetter. Basically, he looked at how Windows Hello for Business works in on-prem Active Directory. And this was also the inspiration of the shadow credentials attack in Active Directory by Elad Shamir. Basically, this that makes it possible to write keys to other users and then perform lateral movement with that. So those are some very interesting things. And there's actually quite some parallels with the Azure AD implementation of it. So this was definitely a very useful research. I've also found several research papers that focused on the Windows implementation, bypassing the biometrics, trying to bypass the PIN, the fingerprint, and stuff. But I didn't really find much on how it works in Azure AD. Seemed I was at least the first one to look at that and write about it. There's also been some research about the internal Windows handling of the PIN and the encryption and stuff by several people, among which is Benjamin Delphi. So there's definitely some prior work here, and with this I'm hoping to extend on this further. If we look at some of the key points that Microsoft basically uses to advertise this solution, basically the good thing about this is that Windows Hello for Business provides strong, phishing-resistant multi-factor authentication. Not my words, these are basically what they say about it. It requires MFA to provision, which is also why it's considered a more secure authentication method. It's bound to a specific device, so you cannot like just take the key from the device and use it somewhere else, theory. And if you have a trusted platform module, then the keys are protected by hardware, preventing attackers from stealing the keys, even if they have like full privileges on your endpoint. And this all makes it more secure than password authentication. So keep these points in mind a little. We'll get back to them at the end to see which ones are actually true or not. So if we look at some of the Windows Hello for Business flavors, I already mentioned you have it with Azure AD native, so that's just the native Azure AD implementation of it. You can have it with Active Directory only or in a hybrid setup. And basically, if you look at the Azure AD native, that's always enabled. So if you have Azure AD as an organization, if you use Microsoft 365, then your devices can do Windows Hello for Business, and it's enabled. I don't think there is actually a way to disable it. You can only control whether your devices will start using it or not, but the authentication method is always enabled as far as I know. For Active Directory and for hybrid setups, it's a bit different. It requires some custom setup, can be a complex setup depending on which scenario you use. Especially if we look at hybrid key trust and hybrid certificate trust, you might need ADFS or a PKI infrastructure. So definitely makes it a bit more complex than especially the Azure AD native implementation, because for that you don't need to do anything. So if you look at this implementation in Azure AD, one thing we need is always a device, so a device identity. So to use Windows Hello for Business in Azure AD, you need to have a Azure AD joined or registered device. Usually that will be the user's endpoint that they're using. And if Windows Hello for Business is enabled, then the enrollment will take place at the end of the Windows installation. So if you set up your device the first time and the policy is set up to use it, then it will basically prompt the user to set up Windows Hello. If you enable it later, then whenever you sign in after it's enabled, at some point it will prompt you and say, hey, let's start setting this up. So you get a screen like this, which says, hey, now let's get rid of that password and use Windows Hello. Basically, when you click OK, it will prompt you for multi-factor authentication. There's an important part in it, because, of course, if you could enroll these things without multi-factor authentication, that would be quite bad. So it prompts you for multi-factor authentication, and then after it asks you to set up the local credentials. So there's, I think, always like a backup PIN. Sometimes the primary authentication is the PIN, but you can also use biometrics or face unlock, basically to unlock this local credential on the device. So if you look at the technical components, there's a few things involved here. The first one is the Azure AD device identity. So devices have an identity. That's true for both the on-prem implementation as for the Azure AD implementation. And for Azure AD, the device basically uses a certificate plus a private key to prove its identity to Azure AD. Another thing is a primary refresh token. For those of you who are not familiar with this, basically when you have a device that's connected to Azure AD, then it will get a primary refresh token to do a single sign-on. So with these single sign-on credentials, it will sign in to any other resource. So that's with this, you don't need to have to enter your password and to do MFA anymore, because it uses the primary refresh token. Another part is the Trusted Platform module, or a TPM. And basically, this is some hardware-based protection for private keys, so that even if an attacker has system rights, it cannot extract these private keys because they are stored in hardware. And that is true for the device key from the device identity, the session key from the primary refresh token, and the Windows Hello for Business keys. So if we look at the technical flow, then basically it starts off with redirecting the user to the login.microsoft online. And what we can see here, or well, basically this is a normal OAuth 2 initiation. The thing that springs out here is basically the authentication method values that it requests, which is the NGC MFA. And it's a bit of a special one. You don't see that much in other flows. But basically NGC stands for Next Generation Credentials. This is the internal name that Microsoft uses for basically passwordless credentials. And if there's the requirement to authenticate with NGC MFA, it means that the user should be doing like a fresh MFA authentication, because normally MFA is cached either in the browser session or on the device. But if Azure AD sees that the process needs NGC MFA, it will re-prompt the user for fresh MFA to make sure that the user has access to their MFA methods. This is reflected as a claim in the access tokens that are issued. So if you decode this, then you see that I, in this case, authenticated with the password, with the key, and also with multi-factor authentication, and with this NGC MFA, which indicates that I have a fresh multi-factor authentication. So in order to provision a Windows Hello for Business key, there's a few requirements. So you cannot just do that with any token. It needs to be specifically a token that was issued to a Azure AD joined or registered device. So that means that it should originate from an existing primary refresh token, and that the device ID is basically in the token. It should also contain the NGC MFA claim, which indicates that a recent MFA was performed. I think it's around 10 minutes. And the audience should be the device registration service, because that's basically the endpoint where this key provisioning takes place. Now, the provisioning of a Windows Hello for Business key is, I expected this to be complex, but it's like really simple. It's just a post request with a JSON with here's my public key, please provision this. Of course, it also includes this access token for authentication. But apart from that, it's just a post like here's the public key. Good luck with it. The response is equally simple. There's this CTX. This is not used in most flavors. I think you need this for certificate-based or hybrid scenarios, basically. But it basically says, okay, I've registered your key and everything is fine. So now this Windows Hello for Business key is registered and it can be used to authenticate. And Windows will do that to obtain a primary refresh token that's basically backed by this key. So it will send a post request to the token endpoint containing some JSON web token data, basically. So we see a lot of encoded stuff here. And if we decode that, then we see that this contains a JSON web token. So this is a signed request, basically, to prove that it came from the device. It contains the device certificate in the header, so that Azure AD knows which device made this request. And then in the body, it shows several parts as well. So we have the request nonce. This is a very common occurrence when you see primary refresh tokens being used. It always uses this nonce to basically prevent replay attacks, because the nonce expires after a few minutes. We see the username that's authenticating, and we see something that's called an assertion. And here we have another JSON web token. So there's a JSON web token in a JSON web token. And this whole payload is basically signed with the device certificate and the private key, so that Azure AD can validate it's actually from the device. And if we decode this assertion, so we have another signed payload. And this one is signed with the private key of the Windows Hello for Business key that we just provisioned. So we see in the header, we see the key ID that was used, so that Azure AD can look up the key. The usage is NGC to indicate like we're using NetGen credentials. And in the payload, you see some variables again. So the user that is authenticating, the audience, which is the tenant ID, and you see some issued at and expiry times, basically to prevent replay attacks again, because this will obviously expire after the expiry date is gone. All right. So we send this to Azure AD, and Azure AD gives us back a primary refresh token. So in this response, we see the refresh token, which is the primary refresh token at the top. We see the session key, which is basically an encrypted blob, so that the device needs to decrypt that in order to get the session key that's needed to use the primary refresh token. And we also see some Kerberos stuff at the bottom. We'll get into that later. So I basically emulated this flow with RoTX. RoTX is part of my RoTools framework, and RoTX now also supports like doing this key provisioning, so it can generate keys. It can request an enrollment token with the right NGC MFA claim, and it can also request primary refresh tokens with the private keys that are generated. So a quick demo. So basically here we start off by requesting a normal primary refresh token. So this uses the username and password of the user. And then once we have the normal primary refresh token, we can upgrade that with MFA. So here we have the normal primary refresh token. Now I use the PRT enrich command. So the PRT enrich command, it will prompt for the MFA authentication on top. And I also indicate that I want to have this NGC MFA claim in my token. So, so it will pop up a browser window in which we can enter the MFA code. So now we basically enrich our token with the MFA claim. And now with this access token that I get from this, I can register this Windows Hello key. So I specify the key that it needs to be saved to. It saves the key basically on disk. So now I have generated this key, obviously not in the TPM, but it's on my local disk. And I can also then request a new primary refresh token. And in this case, I'm requesting a primary refresh token using this private key that we just provisioned. And with this primary refresh token, I can also get some access tokens. And if we look at the access token that we get from here, we see that the authentication methods are RSA and MFA, and this indicates that we used basically a private key to authenticate and also MFA. So we see that there's no PWD claim in here, so we didn't use a password, but we used a passwordless method to authenticate. So this is how you can basically enroll a Windows Hello for Business key if you have the user credentials and the user's MFA information. So I dug a bit more in this and I analyzed this whole process. And first of all, something to note that the full provisioning process is controlled by the client. So you have policies that you can set whether or not the client will, whether or not Windows will prompt for Windows Hello enrollment, but it's always possible. So even if you don't have the policy enabled that your device will do it, you can still do it manually. And as a result, any user plus device combination in your tenant, so also if you allow people to have private devices registered in your tenant, they can also be used to register Windows Hello keys. So even if you have an Android phone connected to your corporate thing, in theory that could use Windows Hello, even though Android obviously doesn't support that. So looking at the provisioning process again, we notice that there are two parts in this. Well, of course, the public key on the bottom we can just generate ourselves. That's not an issue. So the only thing that really is important here is the access token and how that's checked. And it turned out that the NGC MFA was in fact not required in practice. So basically, we could have any token that had an MFA claim in it, and we could use that to provision a new key. So if you have, if you're on a red team, you have a session on a user device, or you have their cookies dumped, or you find some other way to access a user's device, then with the single sign-on material that's already on the device, we could basically provision a new key and use that key to provide persistence to the user. So just to have a schematic of this attack, imagine an attacker is running on the endpoint. They have some low privilege access. You don't need admin access for it. You can just request single sign-on data from LSS. And with that single sign-on data, you could basically provision a new key. And then you would have authentication access that you could use on the other device. And in this case, of course, all the credentials were protected by the TPM. So this device has a TPM, everything is secure in there. We cannot steal it from the TPM, but we can simply request the single sign-on data and provision a new key that we control ourselves. So the whole TPM protection in this case doesn't really matter if we can just provision a new key, basically. So this is how that looks. In this case, I'm using row token. There's also other ways to do this. There are some beacon object files for Cobalt Strike if you want to do this. Basically request the single sign-on data. And then you can use that to get a token. So you can get a token for the device registration service using RowTX, for example, and this PRT cookie, as it's called. And then with this access token, you can basically provision a new Windows Hello for Business key. And now we have a key that's saved on disk, and we can just request new primary refresh tokens that are valid for this user. So now we have persistent access to the user's identity, even if we lose access to the device, basically. So the TLDR, basically it was possible to overwrite the registered Windows Hello for Business key from a device using a single sign-on. This kind of defeats the whole, the key is in the TPM and you cannot extract it. It doesn't matter if you can just override it with a new key. So this is a nice way of having persistency. And also Windows Hello for Business key can be used with any device. So even if the key was technically provisioned on this device, any other device could also use that private key. It's a feature, it's required in some scenarios, so it's not necessarily needed to use the specific device identity the key is linked to. With some tricks, you can also restore the original key so that the user's device actually keeps working, because of course if you overwrite the key, then the original device wouldn't work anymore. So now we looked at the endpoint perspective. Let's have a look from the perspective of Azure AD. So if we look at Azure AD, we can see the ways that Azure AD basically stores Windows Hello for Business keys. In this case, we're using the graph.windows.net API, the internal version, and this basically gives us a property called searchable device key. And here we just see the public keys that the user has registered. So we can list all the Windows Hello for Business keys. We also see the device that they were provisioned to. And it turns out that users can actually modify their own searchable device keys attribute. So if you have permissions or if you have access to a user account, you can just basically inject a new key in here without any specific requirements. So you don't need MFA to do this as long as there's no specific policy that requires you to perform MFA. If there is no policy that requires MFA in all cases, then it would be possible to bypass MFA via this case. So this depends a bit on the conditional access, but there is no specific requirements other than having a token for this specific API. You also needed to have a device in the tenant. That could be a legitimate device or a device the attacker basically registers, and usually anyone is allowed to register devices. And apart from that, just with a valid access token, we can provision this new key. So that was pretty easy. There's also a command in RoTX to basically generate these keys. It will just print the JSON that you need to add. And then with a simple HTTP patch request in this case, so we turned the get into a patch. We're just inserting a new RSA public key in this list of Windows Hello for Business keys, and then we can also authenticate as the user using multi-factor authentication credentials. So one of the attack methods for this is device code phishing. So I'm not sure if you're all familiar with this, but basically device code phishing relies on initiating the flow on one host and then have the user enter the code on a different device. So the attacker would initiate the device code flow from their device by talking to Azure AD, and then phish the user basically into authenticating with that specific device code. And if they do that, then it will actually be the attacker's device that is authenticated. So in this case, the attacker received the access token, and with that access token, the attacker can talk with the various APIs. So with that access token, the attacker could just register a new device, basically, and also register a Windows Hello for Business key for the user. And then they have persistent passwordless credentials, which count as MFA credentials as well. And they also meet basically the requirements of having the strongest MFA level that there is, because by default, Windows Hello for Business is considered one of the strongest MFA methods there is. So there's some alternative scenarios here. So I already mentioned device code phishing. Of course, with normal credential phishing, that also works. So if you use a tool like Evilgenics, you could also do this. If you have temporary access to someone's device that they left unlocked, you could use this with single sign-on tokens. And also a neat thing is that if you have an admin account that's allowed to basically modify other users, such as a user administrator or a global administrator, these users could also provision keys on other users. So then you could basically do lateral movement between users using these passwordless credentials. And we'll get into that a bit more in a bit. So we looked at the endpoint, we looked at Azure AD, and the last one I want to look at is some hybrid scenarios. So if we look at how Windows Hello for Business works in a hybrid setup, basically there's three methods. The first one is Cloud Kerberos Trust, the second is Hybrid Key Trust, and the third is Hybrid Certificate Trust. I've only really looked much at the Cloud Kerberos Trust, first because it contains Kerberos, and second because it is the Microsoft recommended way of deploying it. So it's the simplest method which has the least dependencies on-prem. Like for Hybrid Key Trust and Certificate Trust, you need to have a more complex setup. But the Cloud Kerberos Trust, you just need to run some PowerShell scripts, install some GPOs, and then it works basically. So Windows Hello for Business Cloud Kerberos Trust is quite an interesting concept. So we start with Active Directory and an Azure AD. And basically, once you set up the Cloud Kerberos Trust, then it creates like a virtual read-only domain controller in Active Directory. I mean virtual because there's no real server, of course, behind this. It's just an object. And basically, the Kerberos keys are shared between Active Directory and also between Azure AD. So in this case, you're kind of setting up a trust between Active Directory and Azure AD. And now when a user authenticates with Windows Hello for Business authentication to Azure AD, then Azure AD can provide some Kerberos tickets, which is called a partial TGT. So Azure AD can send a TGT for the user, but obviously Azure AD doesn't know like all the information about it, but it sends a partial TGT that's signed with the Kerberos key of the virtual read-only domain controller. And then the user can basically talk to Active Directory and exchange this for a full ticket granting ticket. A nice part of this is also that the user can obtain the NT hash for the original account, because of course, if you use certificates to authenticate, then the endpoint doesn't have the password because there's no password entered, so it needs to somehow have the NT hash to still do legacy authentication with NTLM, for example. So having a look at how this works in practice, we have this Azure AD Kerberos domain controller, which is the virtual read-only domain controller. So this is not a full domain controller, but it's RODC basically. And when we request a PRT using the Windows Hello for Business keys, we get back a partial TGT that you can exchange for a full TGT. And with the full TGT, we can access any resources in Active Directory, basically. Of course, it only works for hybrid accounts. If you have an account that only exists in Azure AD, then it doesn't exist on-prem, so you cannot get a TGT for that account, no matter what you try. But it basically looks like this. So we previously saw us getting a primary refresh token. Now, if you have the Kerberos, Cloud Kerberos setup, then it will also contain a TGT_AD. And this is basically the partial TGT that can be used to talk to Active Directory. And we look at how to exchange that later. But basically, this allowed some interesting properties. So because user administrators or higher roles basically could provision keys on other users, it was possible to move laterally if you have admin privileges in Azure AD. There are some restrictions that apply, so Azure AD is quite strict on which admin roles can modify other users, but any non-protected user was basically vulnerable to this. So if you had access to a user administrator account, you could provision keys on any other user and authenticate as them. And it's also in this way possible to move between hybrid identities. So if you have if you provision a key on someone else's account, then you can use that to get a PRT. You can use that to get a TGT in on their behalf, and you can basically use that to authenticate in Active Directory as well. The only users that it doesn't work for are domain admins and some other basically tier 0 equivalent accounts, because these are basically protected accounts, and the virtual read-only domain controller doesn't have privileges to to get keys for these users. So it's not allowed to give out TGTs on those. So there's some restrictions, but for normal users, this would definitely work between any identity. The only additional requirement is that you would have line of sight to a domain controller, of course. So if you only have access to Azure AD and you don't have any access to the on-prem domain controllers, then this will not work. So you will need either you will need to be able to talk to a domain controller in order to capitalize on this and get the TGTs. All right, so just having a look at how this works in practice. So if I authenticate as a user that is a hybrid user and has a Windows Hello for Business key provisioned, so I'm using this hybrid at the hybrid.I'm in your cloud domain with the Windows Hello key that I registered for this user. And I'm also using a device identity because you need a device identity in order to do this authentication. I get a session key, I get a primary refresh token that's basically saved on disk. Then I can extract this TGT from the PRT file. I can do this with the lowticket.py. There's also a different tool that can do this. I'll get to that later. But basically, I can extract the TGT from the JSON into a C cache, and that I can use with the normal Impacker tools. So in this case, the getst.py, so this uses the service ticket requests, but with the target KEB TGT. So it's basically requesting a full TGT based on the partial TGT that we get. And that saves the full TGT in the hybrid.c cache file. So now we have a full TGT for this user. So what about NTLM? So of course, if you use Kerberos, then and you don't have a password, then Windows will not have the NT hash because it cannot calculate this. So basically, Microsoft added a new method to their Kerberos implementation, which allows the protocol to basically recover the NT hash during the TGT upgrades. This is documented in MS Kyle, and basically it looks a bit like this. So this is the TGS-rec. So basically, this is the request to upgrade our partial TGT to a full TGT. We see that the target here is the KEB TGT, so that's how we know that this is a request to get a ticket granting ticket. As pre-authentication data, we have our partial TGT, so this proves to the domain controller that we are in fact authenticated as that account. And there's also this pre-authentication data unknown with type 161, and this is the, if you read the documentation, basically this is the request to get the NT hash back for this account. So this only works in some limited scenarios. I don't know exactly what the requirements are, but you cannot do this with a regular TGT by just including a structure. So it has to be a partial one, and I think also from a read-only domain controller account. So there's some restrictions on this. But basically, if you use this legitimate way with Azure AD Kerberos, then you will get a TGT upgrade reply. This is a normal reply. You have the encrypted part here that is encrypted with the basically with the session key, so the user can decrypt this. And in this part we have the NT hash. So that's the one here, and this contains the NT hash for this account. So then Windows can load that into LSASS, and then it can also do NTLM authentication to any resources that don't support Kerberos. Of course, there's also a tool for this. This is part of the RoTools hybrid repository. By the way, this is based on research from Leandro Cuso, who basically looked at this keylist attack. That you can also use this for some other nice attacks, but basically this is the legitimate implementation to exchange a partial TGT to a full TGT and also recover the NT hash of the user. So, of course, in this case, we could laterally move and between users if you have a privileged enough account, and we could also then recover the NT hash for these users. And of course, you can try to crack that one or just use the NT hash to authenticate as the user. So this also brings us to some key trust consequences, I guess. So if you use Kerberos Key Trust, Windows Hello is not the only scenario in which you would do that. It's also the way to have FIDO2 authentication to your on-prem domain. So even if a company doesn't use Windows Hello for Business, they could still have Kerberos Key Trust. But this establishes basically a trust relationship from the on-prem domain towards Azure AD. Usually it's the other way around because the on-prem domain pushes information into Azure AD, but in this way, basically the on-prem Active Directory trusts Azure AD to do the authentication, to provide Kerberos tickets, and Azure AD basically manages the keys of this read-only domain controller that's stored in Active Directory. So Azure AD has some highly privileged credentials that could grant control over your Active Directory, basically. So as a result, if you have a global admin in Azure AD with network connectivity to a domain controller, so it's not fully cloud-only attack, you always need have to have some network connectivity. Basically, a global admin, by definition, can modify accounts in Azure AD, can provision passwordless credentials for them, and then also recover the NT hash basically for most synced users, so not for domain admins or other high privileged groups. Well, not that you should be syncing your domain admins anyway, but basically for any synced user that's not a highly privileged user, the global admin could recover the NT hash as long as they have some network connectivity to on-prem AD. Using this way, basically a global admin can also obtain domain admin privileges just because of how you establish this trust between on-prem Active Directory and Azure AD. So just to end up with some conclusions and some words on the disclosure. I disclosed all these cases in basically October 2022 to Microsoft, and during February to April, there was some back and forth about the fix timeline. Of course, some of these issues were quite complex, so it required some time to fix. Also had some discussion about bounty classification, some disagreements on what should or shouldn't be bounty eligible in scope, what's identity related or not. I'll save you that headache. Basically in May 2023, so a couple of weeks ago, Microsoft rolled out fixes for most of the cases. So now it's not possible anymore to provision new keys by writing to the searchable device key property. And it also now requires NGC MFA properly to provision a new key via the device registration service. So you can't just like modify users and then just have arbitrary keys on them. So that's an improvement. Of course, for getting back to the Active Directory story, in Active Directory this is still possible. The shadow credentials attack still works, but in Azure AD at least this is fixed. So to get back to the conclusions, I started with the key points basically. So whether Windows Hello for Business provides strong phishing-resistant multi-factor authentication, I think it's a bit questionable. It certainly wasn't phishing-resistant because you could actually enroll keys with phishing. So I wouldn't call that phishing-resistant. And even now, like from the perspective of Azure AD, all that gets posted is like this public RSA key. It doesn't prove anything about where that key is stored, how it was generated, if it's stored in a TPM or not. So calling it multi-factor authentication kind of works, assuming that the device that it was provisioned from is fully trusted, which is a bit of a bad assumption, I think. So I would probably call this 1.5 factor authentication. If you have very tight control over your devices and you look at which devices actually provision keys, then you could treat it as multi-factor authentication, but it still only relies on that specific RSA key that's provisioned, and how that key is unlocked. It's really up to your devices and also how it's protected. So requiring MFA to provision, well, definitely wasn't true. I guess it's more or less true now. It was also not bound to a specific device, so basically you could use the keys that you provision from one device. If you steal the keys, you can also use them with another device. The keys being protected by a TPM, that's more or less true. We saw some demos that you could basically, without stealing the key from the TPM, you could still override it. There are some more possibilities here. Those are not yet patched, so that's a story for another time. And there's some more interesting things here. But still, overall, I would definitely say that this is more secure than password authentication, because passwords are just insecure in general. So it's definitely better than passwords, but I wouldn't call this like the most secure form of authentication that you could think of. Lastly, to end up, all the tools in the talks are based on the Road Tools framework. They're all open source. All the things that I have talked about, you can download them from GitHub. You can look at it yourself. You can do the flows. You can play with it. There's also the Road Tools Hybrid library that contains more or less the hybrid tools, basically, because they use some Kerberos libraries that I didn't want to include in the main Road Tools repository. I also have some Road Tools stickers, so if you want some stickers, then hit me up after. And of course, I'd be happy to take some questions. If you don't have any questions here, you can find me later. You can message me on Twitter, send me an email, whatever works for you. So thanks.